How do you find the greatest common factor and least common multiple of two numbers? And for this example, we're going to use the numbers 225 and 270. Now, what is meant by the greatest common factor and the least common multiple of two numbers? Well, the greatest common factor is the largest number that divides evenly into 225 and 270. The least common multiple is the smallest number that each of these numbers can divide into evenly. To find the GCF and the LCM of two numbers, we have to first find the prime factorization of the numbers. And we can do that by creating factor trees. What we're going to do is break down each of these numbers into its simplest parts. And that would be the product of prime numbers. So let's see how that works. To begin the factor tree, I have to think of two numbers that multiply together to give 225. In order to do that, I need to think about divisibility rules. The number 225 ends with the digit 5. That means 5 must be a factor of this number. Now I have to think of a number that I can multiply by 5 to get 225. And that number is 45. Now the number 5 is prime, so that part of the factor tree is finished. The number 45 is not prime. It has more factors. So we can continue to break down this number. And I know that 5 times 9 will give me a product of 45. We know that 5 is a prime number, but 9 has more factors. We can break 9 down to 3 times 3. And 3 is a prime number. So the number 225, written as a product of prime numbers, is 3 times 3 times 5 times 5. Now we'll do the same thing for the number 270. 270 ends in a 0, so I know it's a multiple of 10. So 10 is going to be a factor. Now I have to think of a number I can multiply by 10 to make 270. Well, that would be 27. Now neither of these numbers are prime, so I have to break both numbers down further. 10 is the product of 2 multiplied by 5. Both 2 and 5 are prime numbers, so I've finished this branch of the tree. 27 is the product of 3 and 9. 3 is prime, but 9 can be factored further. And 9 is 3 times 3. So the prime factorization of 270 is 2 times 3 times 3 times 3 times 5. So now I've found the prime factorization of each number. And what can I do with that information? Well, I'm going to use a Venn diagram to organize this a little better for us. And a Venn diagram is a set of overlapping circles. The circle on the left will represent the prime factorization of the number 225. The circle on the right will represent the prime factorization of the number 270. In the space where the two circles overlap, or where they intersect, is where I'll place the numbers that are in common to both prime factorizations. So let's begin with the prime factorization for the number 225. The number 3 appears in each prime factorization. So I'm going to write it in the intersecting part. And I'll do the same for the other 3 because it also appears in both prime factorizations. The next digit is a 5, and that appears in the prime factorization for 270. So that's going to end up in the overlapping area. So all I have left for the prime factorization of 225 is the number 5. So I'll place that in the other part of the circle. And now I'm done with 225. Now let's look at 270. All that we have left are the numbers 2 and 3. So we'll place those in this circle. Now the greatest common factor is the product of the numbers that are in this overlap area. So that would be 3 times 3 times 5. And 3 times 3 is 9. 9 times 5 equals 45. What this means is that 45 is the largest number that will divide evenly into 225 and into 270. Now let's find the least common multiple. That would be the product of all of the numbers you see in the Venn diagram. So that would be 5 times 5 times 3 times 3 times 3 times 2. And that equals 5 times 5 is 25 times 2 is 50. 3 times 3 is 9, and 9 times 50 is 450. And 450 times 3 equals 1,350. That means that 1,350 is the smallest number that both 225 and 270 can divide into evenly.